Hello guys, welcome to Math Side Trips, a channel for math teachers, students, coaches, trainers, and enthusiasts. Thank you for sparing time and effort to visit this channel. Many of the topics that have been discussed and will be discussed in this channel are those that are not usually taken up in mainstream classroom instruction. We hope that you will find in this channel something new, interesting, or useful. So this is our channel name, Mathematical Side Trips. By the way, I am Napoleon A. Gacking Jr., a math teacher. In this video, discussion will focus on the construction of simplification expressions involving irrational numbers, starting with the answer. We begin by taking a look at the following simplification exercises. Okay, so we have 5 simplification exercises, and we simplify this by rationalizing the denominator, each one of them. So this is rationalizing the denominator problem. Okay, the first set, 1 to 4, involves only one irrational number, while here, from 5 to 6, each one involves at least two irrational numbers. For example, in number 5, there's square root of 6, we have square root of 5, and we also have square root of 3. And there are 4 fractions to be added or subtracted involving these irrational numbers. So this is a little bit more difficult. It's more difficult to simplify them, but it is very easy to construct them, as you will see very shortly. The answers to the first 4 problems are 2 plus square root of 2, 2 plus square root of 3, 2 plus square root of 5, and 2 plus square root of 7, in that order. On the other hand, the answers to problems 5, 6, and 7 and 8 are square root of 2, square root of 3, square root of 5, and square root of 7, again in that order. Yes, they have been verified, but that's not the reason why the answers are easily known. These problems have been constructed starting with the answer. So those answers that have been given a few moments ago, those are the starting points. So, however, we use identities, which is discussed in a previous video. A calculator was used to simplify these expressions, not really to verify the answers, but to see if this particular calculator could handle these problems. And it turns out that the calculator used here could handle the first 4 exercises, but could not accommodate the 4th fraction of irrationals for each of the next 4 exercises. So the question is, how were they constructed? As I said earlier, it's actually easier than you think. Recall one of the identities that have been constructed in a previous video. This one, x plus 2 is identical to 2x squared minus x over 2x plus 3 plus 4x minus 3 over 3x minus 2 plus 16x squared minus 4x minus 3 over 6x squared plus 5x minus 6. Since this is an identity, The equality must be true for all permissible values of x, including irrational numbers. So we embed or we replace x with irrational numbers instead of integers or other rational numbers. So here we use x equals square root of 2, x equals square root of 3, square root of 5, and square root of 7 in succession. So we got the first 4 simplification exercises. For example, in number 1, we have g of 2, g of square root of 2 is equal to square root of 2 plus 2. So that's our g of x. And f of x, when x is replaced with square root of 2, we have, remember that f of x is just the expanded form of the original expression g of x. So we now have the first problem in the first set, no? 4 minus square root of 2 over 3 plus 2 square root of 2 plus 4 square root of 2 minus 3 over 3 square root of 2 minus 2 plus 29 minus 4 square root of 2 over 6 plus 5 square root of 2, which when simplified will give you, of course, 2 plus square root of 2. On the other hand, to obtain the next 4 exercises, we first construct another identity. So we start with the expression x, write it as 3x over 2 minus x over 2, and then introduce another variable y by multiplying the first one by 2y plus 1 over 2y plus 1, which is essentially 1, and multiplying the second x over 2 by y minus 2 over y minus 2, which is 1 also, and we get this new expressions. And then we break them down, getting these 4 rational expressions involving 3 variables now. So we introduce a third variable by doing this in the first expression above. So by adding 2z minus 2z, and on the other in the second fraction by adding 4z, but at the same time subtracting 4z, and then split the 2, and we get this 4 rational expressions involving x, y, and z. Then when the order triple x, y, z, so when the variables x, y, z are replaced with these numbers, square root of 2 for x, square root of 3 for y, and square root of 5 for z, and then square root of 3 for x, square root of 5 for y, and square root of 7 for z, and so on. In succession, we obtain simplification exercises 4, 5, 6, 7, and 8. The sample exercises given above are not really typical classroom questions. The simplification problems that follow are more familiar. Okay, so this is more familiar. We see this in textbooks on college algebra. And these 4 simplification exercises come from the identity x plus 3 over 3x plus 5 is identical to 4x squared minus 4x minus 3 over 6x squared plus x minus 15 minus x squared minus 3x plus 2 over 3x squared plus 2x minus 5. So we get this by using irrational numbers. In number 1, by replacing x with square root of 2. And in number 2, by replacing x with square root of 3. In number 5, by replacing x with square root of 5. And in number 4, by replacing x with square root of 7. That is all for now. The next video is about simplification of expressions involving cube roots and numbers of the form square root of a plus or minus b square root of z, where z is not a perfect square, etc. God bless.